What's up, ladies and gentlemen? It's Papa Bale. Welcome to the channel. In this live, we'll be exploring the Trifilar coils, which are these two right here. We'll get meter readings on both of those third strands. And we're going to be exploring contactless dynamos over here. They're not here yet, but we are going to hook them up as soon as they get here. So that's going to be awesome. We'll get all that extra energy off the top there. All right, so currently in this Trifilar is lighting up this light and this light. And they're very dim, so I'm thinking that the 20 gauge strand is a little thick for the so we got this LED right here being lit up. And this one right here. Don't know if you can see it. There's a green and a blue one. And then this one over here is a 22 gauge strand, and it's a lot more wire. See, the coil's twice as thick. But we turn this one on, and they're lighting up 4, like twice as bright as over here. So more wire, thinner gauge. And this is only going at 8 volts. That's pretty awesome. It's about 340 milliamps. Oh. And this is all on 12 volts for this motor over here. I had these halogen bulbs. Wow, I'm going to have to get something to drink. Hooked up in here. They wouldn't light up, but the other lights lit up. So complete circuit, allowed for everything to happen. But they're 120 volt halogen bulbs, and yeah, they work a little differently. So I love that I got all this stuff to work. Especially that one over there. Mm. So, yeah, happy holidays, everybody. It's going to be like that for me for the next week and a half or so, a month or so, actually, you know, straight up through Christmas. But like right now is big. I don't know. Kids are off of school and it's just holiday festive. All right. So with the top, I was thinking 2 9-volt batteries in series. But then I was also thinking that I would have to change the rotor type to a 180 degrees and then have 2 coils in here to balance the weight, and then have the batteries over here and the circuitry cross from the batteries. And I think that'll work better than the 3. I don't know if I need to change it, but I need to balance the weight in the bottom. But the 3 might work, you know, because it's balanced. It's balance. It's just the disc here that needs to balance. So, I mean, either way it goes, I could make the other rotor and see if it works better. I'm thinking I'm going to raise the rotor up just a little bit because it'll still work, but I want it to be able to clear everything nice and good. And then I don't know about sawing off the rest of the shaft will be the last thing that I do. But that right there is like the top, the dreidel. Yeah, but it needs a little bit more. Space is going to be an issue, and me building this thing is going to be a marvel because I don't work well in tight spaces. That's why everything's 8 inches big, because I don't do this. I do this. So I work on all this stuff is based around me and what I can do, and it doesn't conform very well. Now, 4 inches, I could probably do that. You know, I'm working with this one over here where it's 4 inches. You know, 4 inches is good. It's a good size. I don't know if those bearings are good right now, but I wonder if there's a way to find out. I wonder if these magnets right here will set these coils off. I doubt it, but we'll try it. I mean, if they do, I'll start to think differently about stuff. I really will. All right, let's give it a whack. I'm not moving the third one because it's glued. We're going to leave it there. All right, here we go. Let's see what we get. We got it. I don't know if it's going to keep going though. We got one to light up for a little bit. Oh man. All right, that is definitely wires touching. We don't want that. Yeah, and the board is really messed up, so. So I'm thinking maybe if I put, because this is just I don't think that doesn't sound right. Oh, and when this one's on, stuck on position, this one's light lights up. So that's really strong there, just being that close. I wonder if we do this and then like straighten it out. It's a mess. Well, it's not going to keep spinning, but I like what I see, kind of. One would say that that's definitely a transistor blown. But I think if I can get it where it just stops, it'll work. It'll work 100%. It'll work. All right, but the way it is with the wire, whatever wire is crossed, it's not going to work. But I'll jostle it around and it'll turn off and then it'll run. It'll run the right way. I'm sure that if we balance that rotor out a little bit more, that it will definitely. Now something gave way right there. All right, let's see. Okay, definitely some crossed wires there. It's not funny. Man, I hate this 18 gauge, man. It's like so. Mm, now either it's all working now and we got it straight, or something happened just then. We'll find out. We will find out. Here we go. Something happened. Oh man. Huh. Oh, that sucks. Hmm. I hope that's just a transistor. Anyway, it kind of sucks. What the helios? All right, here we go. Wow. Wow, what a mess. Holy cow. Oh, yeah. So there is our first in like a long time actually. We haven't had too much damage done in a long time. So that's actually pretty good. That sucks though, where it's at, man. That's not good. Feel kind of ashamed. I mean, I hope I can fix whatever's going on with that. Pull like a hard reset, and then like maybe get a different coil. Yeah, a different coil would probably be good at this particular point. I hope it's not too late. Because I know this stuff is fragile, man. It's the only way to describe it. It's awesome, but it's delicate, extremely delicate. I gotta say, these two circuits have been the most versatile, though. for being so delicate, they get the job done. So I'm taking out the 18 gauge Trifilar and putting in, well, it is a Trifilar, but it's two strands of 26. So I usually just put them together. My cat just attacked me. That's awesome. All right, I need to get my multimeter. There it is. Oy. So we'll have this one be the trigger strand, and the other one will be the third wheel. It'll be a 26 gauge strand. It should be pretty good at getting electricity. What the hell is going on? All right. This is the thing with moving. We're just trying to mark this real quick. That. Hello, everybody. Welcome to the channel. All right. We just had a snafu here, like a problem, like I saw smoke. And then we got no response after that. So I was bumming. So we're going to change up the coil, give it a hard reset, and see if it functions. And if not, I don't have a transistor to put in there right now. Now, this is half of the previous trigger of this coil, because it was a double 26 and now it's just a single 26. I don't know what's going on with the circuit, so we'll see what's up. Hmm. Well, I don't know. I don't think it's the transistor, though. I don't. That's unfortunate. I don't know if there's a way we can test. Oh man, it's either not long enough or something has happened. All right. I gotta bathe myself in actually we're gonna stop this. We're gonna turn it the other way. Yeah, that sucks, man. Probably should have been using this coil the whole time. I got an idea. Since there was smoke on these things, I'm guessing that one of them isn't good anymore. At least one of them. You know, I'm gonna switch them all with bigger ones. Yeah, these are pieces of crap. No, I don't even know, dude. They're terrible. Since I don't know which one it was, they all gotta get switched. I don't know if I have any more large ones. Let me check. All right, just enough. All right. And if this doesn't work, then it's definitely I fried it, and I feel so dumb. Because if it was a blown transistor, it would be looking like a blown transistor, not like it's just totally unresponsive. And then it could be that the trigger strand is now not enough, but I don't want to believe that. We got it. Oh, oh, yeah. Oh man, I like it when I know what's going on. You know. All right. Thank you, but Jesus. All right. And so we'll turn on this one. So cool, man. Yes, man. It's triumphant. I'm gonna walk down the street like I conquered an army, man. Like, whoa. They're like, don't let it go to your head, man. Hell yeah. Hell yeah. All right. So how much is this one going on? This is 8.5 volts, 300 milliamps. See what 12 volts. 12 volts is about point. It's 450 milliamps. And that we're gonna get a contactless dynamo that's gonna go across here. Maybe two on there. One for here, one for here. We're gonna see what we can get off of that. It's on its way. It's in the mail. I love it, man. Sweet. We figured it out. We fixed it. And wow, it's working. All right, let's get our lights hooked up. I forgot where I put them. Oh well. Let's try to find them real quick. Here they go. So we'll go for our third strand. All right, we're going to see what our pickup is off of this. Not much. Huh. So we're going to rethink this. We're going to get our multimeter and we're going to hook that up instead. See what's going through there, if anything. Seven volts. 7.5 AC volts. We're only getting 3 volts from this, from the power. Yeah, that's not enough to light 2 of them. Maybe it can light 1. So it's not 1-to-1 on this coil, but it's 1-to-1 on this one. I mean, you put in 12, you're going to get 12 out on this one. But here, you put in 12 in, you're getting 7.6 out. I wonder why. And that's with a 26 gauge strand. Oh, that's a little disappointing. And then, but with induction, with the magnets passing, you get about 5 volts. So you level off at about 8. And here you get some extra from the magnets here. It's awesome. It's nothing new. I mean, it's just visual aid to help you see that you're still getting energy. At least you were at a certain rate of speed, getting enough to light all 4 of those LEDs. Mm. So what do I want to know? So we're going to connect one end of the multimeter here, and we're going to connect the other end somewhere over there as well. right here. I astound myself sometimes with my ability to see what's going on here. All right, so man, just there you go. We're gonna turn it on. $12 volts of AC, 11, 12. So it's in between 11 and 12. It'll get up to 15 and then it'll drop. Something to do, I believe, with the potential or the capacitance of the coil itself. Because it'll get up in voltage and then it'll drop down from up to like 15 and it'll drop to 12. Oh, so weird. Okay. These are really bright. And then there's this one that's like not bright. That's the first one in the loop too. That's the least bright. Oh no. All right. So yeah, that's all right. Now, I was trying to use this pot with like, because the battery's getting low, right? And so I was using the power supply to the battery to power the pot, but it started getting low. So I switched the power supply of the transistor to a different battery, and then the pot wouldn't work using a different battery. Just a heads up. So, like when they say common ground, they mean that. Yeah, I mean, okay, it's all right. You're doing different stuff. It's cool, man. I'm really, I'm digging it, man. The whole electrifying the water. That's cool, man. And like everywhere that wire goes and like connects to your is an extension of your Tesla coil, basically, which is awesome, man. Whatever you're electrifying. See, now it's down to 10.5 volts. Now, what could that be from? I mean, I don't know. It's hooked up to a power supply. It's not draining the battery or anything. I mean, what is going on though? I don't know. It's 10.67. It might be the interaction between these two coils. I always wonder about that. So I'll turn that one off and see if this one goes back up. Yeah, there it goes. 13. So, I mean, maybe it'll even work way better if it's just by itself. Because that's the typical motor, just a one coil. Oh, it's about the same. We'll see in a little bit whether it goes up or not. And I really like how, I hope this one still is working. Still is working, I hope. All right, let's see. Well, we gotta get this all up in here. Come on, man. Uh, all right, we'll see how far it goes. Look, man. Oh, that's brilliant. Let me move the camera. Maybe you can see that. It's totally out. The coil is like totally not underneath the motor and the axial flux. And it's still making it move, man. That's pretty cool. That's funny. Yeah, there's too much weight on the coil right now. It's not glued down, so it's kind of moving everywhere. Yeah, I could do that, but I'm probably gonna mess something up doing it. So I'm not gonna move all that wire down there and balance it out so it stays. I'm not gonna do it. I want to, obviously, because I'm talking about it, but I don't know. I I think 3 magnets in this rotor is a good idea instead of 9. And I want to start, working on my sculpture thing again. I want to make discs that'll spin, one here and one here. And then I want to make a second level and have it spin out here and out here. Wow, this is getting complicated. Okay, here we go. There we are. So I got a lot of poles that we're going to use, and they're going to go around this thing like that. And then we're going to have different levels of discs, like the staircase. I've been talking about it forever. We're going to finally get down to doing it. And I think really what will work very well is 3 magnets. I know 9 is not going to work very well. And it does look like a good centerpiece for the whole thing. The alien green, I'm digging it, man, for the pump action brakes. All right. So I'll be right back. I'm going to change this into 3. And before, what I want to do before I get started on building that is to refurbish this. So we got some fresh holes. We got a fresh start. But that in and of itself is probably going to take a whole day to do, because I have to reuse. I can't build a new one. I can't go out and buy new stuff. I need to reuse what I have. I do have a new face, and I have a new pegboard that we're going to use. And that's the only new part of it. And then there might be a piece of plywood that I can put for extra support for the shafts. Oh, my cat wants to get in somebody's room. I'm like, who's whining? It's my cat. Like, that's awesome. And I think with the bridge rectifier as such, like this, we could definitely get equal DC voltage from the AC voltage. But with all said and done, we're only getting 7.5 volts from this coil, but we get 12 and a half from this one. And it reaches like farther, you know, it goes through 4 LEDs over here, and over here it won't even light 2. And 22 gauge for the third strand. And it's this, the way the coil's wound, you can even see it. It goes this way, like 150 turns layer, and then it goes back 1, 2, 3, all the way back. And then it goes up 150, back 1, 2, 3, up 150, back 1, 2, 3, all the way through this thing. So it's like wound a certain way, specific way. And I believe it's called repulsion. Forgive me if I'm wrong. It's repulsion. And then there's attraction, which is 150 there, 150 back. Or it's the other way around. I'm not quite sure. But yeah, man, it's it definitely, with all the EMF and the transformer part of the whole thing, it makes it work a lot better. All right, I'm gonna go take these magnets out and put them in a different rotor real quick. I'm gonna stay with you guys while I do that because I got my mic on. Hopefully it's got the range. And just to be clear, I'm not done yet. I'm just fixing something. So we'll have 2 rotors now, one with 6 and one with 3. Almost done. All right, so we got 3 and 6. Oh man, that's right. That's a stationary one. So this has got to move down here. Which kind of was already. And then this one. See, one might have thought that was a bum transistor. I almost did. And I remembered something. I got the worst wire setup I could possibly have, and it's definitely a crossed wire. So cool. But, you know, I am going to take precautions. I have to, man. I'm poor. So I was advised to get an insulator for my transistors. All right, so let me get the poles that are going to be used. So these rotors have got to be really light because these poles are 3 feet long. And they're pretty much solid iron. Mm. Man, this is glued or something. That's unfortunate. Anyway, these are the poles. I got a bunch of them. And we're going to stick our pole in here like so. We're going to drill through the wood that's in there. And we're going to have, well, and they're going to go all the way around. You know, they're going to go all the way around. And then we're going to step them up like so, like around here like this. If you can use your imagination, you might be able to figure it out now. But if not, stay tuned, because that's what this whole operation is going to be about shortly. Now I have aluminum tubes that are the same size. Man, this is stuck too. So we got aluminum tubes, and they're hollow in the center, 3 feet in length. So if we want to put wires or something down the center of these, we could do that too. So yeah, this is going to be epic. I mean, it's going to look really cool. It's going to be like a double spiral staircase going around the center disc, and the center disc is going to make the whole thing move. Whoa. Yeah, that center disc is going to make everything move. That's why I think 3 magnets is going to be better. Because I'll be really clear. I'm not an engineer. Of course, I'm not an engineer. I'm more of an artist. I like to paint. But I like this stuff too. So what I'm going to do is I'm going to utilize this to make a sculpture, like art that I appreciate. All right. So I wanna make one right now. What I want to do is I want to get, and we can just use this rotor right here. And we can either do the 6 or we can make it another 3. I think we should make it another 3, don't you? A 120. So we'll just take out this 120. I wish we could make it 2 6s, but we can't because this is a 9 magnet rotor. Yeah, so that 6 is not an option. 3 is an option. I mean, we can do 6 and then we can have the 120 removed. And then it'll be 2, 2, and 2. And that is actually pretty unique design. I don't know if it'll work for this. All right, I need to get a shaft and need to remove the magnets. Well, I'm going to get the shaft first. How you doing, Caleb?
What's this? What's this?
Wow. Wow.
I was sitting on the, I was sitting on the top of the chair like this.
Yeah, I saw that. All right. Now, I want to see if there's any holes in there already. I know I put some holes in here somewhere. Because then if not, I got to get my drill. Because I got a piece of plywood underneath there. So, is that close enough though to get a test off? And then I need to buy more flanges. Those are going to be important. Oh man, there we go. Kinda. I mean, it gives an idea of what would happen. Maybe you can see it knocking. Yeah, but I need my drill, and I need a drill bit, the 1/4 inch drill bit, and I don't have any of that right now. I got my drill though. I mean, I have the drill. I just don't have the drill bit. Man, that is. Oh, where do I have the holes at? Are they right here? Yeah, there's one. I think it's too close though. Let's see. So 6 and 3 kind of work. Not really. Not really. So what we're gonna do, we're gonna remove three magnets. I'll be right back.
This one was 60. What?
What's the 60s, 70s, and 80s?
Years?
Oh, years? For what? Okay. Be careful, I got magnets over here. All right. Now, I don't know if this is going to work out any better. It does. It works better. So the green one isn't going to be the base. That's what we're deciding right now. And 3 and 3 aren't really what we're looking for. We're looking for more. So probably more like this. We're looking for 6. And we're looking probably to go north on north, north. This is north right here. So it's a pushing instead of a pulling kind of thing. So that's what we need. That's actually looking pretty good. But when we start building up, that's when we'll see for real. I want to do that right now, but I don't have another rotor. Here, let me put on some more juice real quick. See if we can't get that going faster. That's sweet. So far, that's awesome. Woo!
What? What's it called? I'm a bit itch too.
Yeah, don't. Well, you can hold it. Just don't pull on it because it's moving. And look at how well synced that is. That's pretty good.
Oh yeah, that's so cool.
That's great, actually. That's sad to get it going a little bit. Wow, man, isn't that spectacular? I think it's great. And then we're going to put one like that on the other side. Sorry, I can't address you guys. I can't see what's going on, but if you can leave a comment, that's good. See what I'm wondering. No, that would be a terrible idea. I was like, maybe we could put this coil on this rotor, but then the sinkage would stop. It would definitely not work anymore. Because the middle one's the one that's actually pushing this one, and that makes it that cooler. Huh. I'll be right back. I also see another issue here. When we start building up, all these rotors are designed to stay together with gravity. So I can see is building up is kind of a problem with the way things are right now. So I'll have to build a different rotor, different type of rotor that will keep it all together when the magnetic forces interact on a vertical level. It's gonna be so cool, man, if I can just get it right. Yeah, well, so there's two projects right here. There's the sculpture, which is gonna be like this, and then it's gonna like go up and around. And at 180 degrees, like so, you're gonna, one will be here and another will be here, and another will start on this side and come this way. So you'll see. You will see if you want to. And then this is going to be the other project. We got counter rotating top. So there's a souped up little dreidel right here that'll spin hopefully fast. Some kind of fast, maybe not really fast because the drive is only 26 gauge. But and then I got to find the proper configuration that'll balance out the stator, and then find the proper rotor for balance as well. I think 3 is good for balance. Really good. But I'm thinking that I only want 2 coils in there though. I don't want 3 coils because that's going to be too many coils. There's only a limited amount of space in there. I want there to be 2 9-volt batteries in series to operate it, so 18 volts. This is awesome. This is, in my opinion, this is epic because it's like fluid. It's effortless. This is great. But can I get another one spinning on the other side is what I'm wondering. I'm pretty sure I can. But that's what I got to do. I got to print out another one of these. Because if I want to use the cube magnets, which are good magnets to use, it should be at least this big. Because you want a good spacing in between each magnet, and you want the magnets to be easy and to use. You know, that you don't want it to be too difficult to put them in the rotor. Now we're going to check out the flywheel capabilities real quick. I'm going to turn it all off. Just looking in the holes to see which holes go through, and I don't see any that go through. No, I'm not seeing it. But it should be 180s for the starter, like the starting level should be 180 degrees. And we could even do, 4 on the base level and work the same pattern. It would look even better, man. It would look sweet. But would it move? Like, would the whole thing move under magnetic tension? I don't know. I think I could get maybe 5 or 6 levels, maybe. So momentum and inertia was what's going to make this thing move awesomely. So yeah, having it be on the motor is going to help it out, I'm pretty sure. So I'm thinking that I'm going to make another one of these style rotors for the other side. And at the same time, I'm going to be cleaning all this up. I'm going to be installing dynamos. I'm going to be doing all kinds of things. That's going to be great. And from what I hear, you can take the dynamo energy and you can put it back in to the system because it's not recognized as being part of the system. Voila. So I don't know. Maybe that'll work. Sweet, sweet, sweet. All right. So yeah, I'm going to print. It's going to be black. Oh, and then it'll go right here. So that's the next one.
Yep.
Mm-hmm.
Okay. Yeah.
All right, so I'm going to put this down right over here. Get that. Okay. So we're going to make some music real quick. Dang. And we're going to put this back. All right. Now let's turn it all on. And it's going to be, I have it set up so no coil is hitting a magnet at the same time. Let me get this closer. It's nice. You know, it's a constant. And then them being so close together kind of cancel each other out. Nope, the other one just wasn't on. I'm just surprised how much energy is coming off of that third wire in there, that third strand. We're going to try that one more time because I screwed it up. See that third one up here wants to start the whole thing. Yeah. I love that sound. That's great. All right. Now, what do I want to do? What do I want to do? I think I want to take this rotor off. I'll adjust the camera. I want to do my 8 magnet rotor. That's what I want to do. Now this rotor is designed to go with the axial like this and spin this way. So it's designed to go the vertical way, and I think it'll be a lot more balanced if it goes that way. That is awesome. That would generate a lot of energy too. Phenomenal cosmic power. That's moving like a speed demon, man. Woo! Like a hairpin. Yeah, see, I mean, the limitless potential almost of a hairpin motor is phenomenal. Because literally all you have to do is upgrade the software and you get more speed. I mean, all the combinations of that probably haven't even been tested yet. Just a hypothesis of my own. So that might be another project that I want to undertake, is having everything tilted on its side and running like that. That's another motor that I could build. I have different components for that already built, but I think I'm going to just start from scratch. Feels really good when you get stuff right and it just works. And it's good also to show people that it's not as easy as you're making it look. You know, show the blunders, show the problems. Like here, there was smoke, and we saw smoke, and I was like, I wonder what the problem is. And then we looked at it, and it was all the connectors that got fried. So we changed out the connectors, and now it works just fine. These transistors are actually pretty durable, honestly, and I don't think that any of, like, some of the problem was burnt transistor, but like some of it was definitely not, as we've seen. And I've burned out quite a few in the last couple of days here. Trying to get my my little homemade. It's not even really a circuit. It's just a bunch of clips clipped to the transistor, but it works. It works. It works good. See, we'll just try it right here. Without fail. You know? So I would say, and they each got their own light too. So definitely a thing. Oh man, I'm digging this 8 magnet axial flux rotor, man. I love it. Zoom in on that real quick. Thank you all. I appreciate the likes. I'm just having fun. If I said I was in it for you, I would definitely be lying, because then I would definitely do more what appeases everybody else. Be doing more of that. If everybody likes this stuff, I really appreciate the likes. I do. So nice, man. Freaking cool. That'll probably keep on going, man. Like, woo! And it's just right there. That's what it's doing. And that's it right there. I'm trying to keep the 2 Primo circuits over here on the main wheel. And then I got one of these over there. And it's awesome. Just look at that thing move. That's great for a couple clips and a transistor. Now, I do have access to high voltage, and I just don't know if any of these components are designed to handle such voltage. I'm talking like 390, 400 DC volts. I don't know if I'm working with anything that can handle that. Mm. Oh, that's so sweet. I'm so glad that I haven't even, this was in mothballs for like a year and a half, 2 years. And the cool part about it is that you flip it and it's open on this side, and you flip it and it's open on this side too. There's no yoke for the magnets. So they're as powerful as they can be all the way to, from beginning to end. See, like here, these three are yoked on the bottom by plastic. It's not terrible, but it is there, and you do have to work your way through it. Wow, those magnets love to push that coil out, man. Like push it all the way out. Now that's a well-balanced rotor. Woo! That's 18 volts. Almost 1900. So like if I get the coil in there and stabilize it, and maybe find a way to stabilize the shaft, because it starts rumbling. I mean, it doesn't shake anything else really, but the shaft starts shaking, and that slows it down a little bit. Yeah, and it's like just think about like hundreds of thousands of one wire power for one motor. I mean, the hairpin, I think each pin has a tremendous amount of power to it. So I don't know, man. It's an interesting technology, and I think however short a time it's here, it'll be useful, or maybe it'll last. Who knows? But like version 1, version 2, version 3 is coming out like ding, 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 ding. It's like The only viable way to do anything these days is open source. The only reason you wouldn't open source stuff, and all this is open source too. I mean, if you want to build a counter rotating top that'll spin and put it on a shelf, man, there's nothing. I'm not trying to stop you. But I mean, when this is done, it should be really easy to use, and it should be able to be packaged very simply. And I'm not going to stop you, but guess what? You're probably going to try and stop me from doing what I want to do because I'm not a dick. Get my drift. All right. Well, I don't know. I think I'm going to call it for right now. Thank you all for hanging out. Really appreciate you. Peace out. Get cracking on all that stuff that I said I was going to do. I'll catch you later. Bye now.